Alright, in this video we will convert a 3NF data model to Data Vault. Let's first have a look at the source model. It shows a sales diagram of an organization. So we have a customer and they just simply go to a store and buy products, and these products belong to different categories. So order table includes the total amount of sales done by customer, and order line table gives the sales detail on the product level. In here, it works as a bridge table to store many-to-many relationship, because an order would include many products and a product will take place in multiple orders. And when you look at the detail, order line tables store also some characteristics like unit price, quantity that belongs to this relationship. And we can also see the cardinality for the rest of the tables as well. Like one customer would have multiple orders, therefore there is a one-to-many relationship, and multiple products would be involved in a single category, so again one-to-many relationship is exist. So let's start the modeling steps. After naming conventions, the first step is defining the hub tables as well as the business keys. So we have two main entities in here, customer and product. When we try to find business key, customer ID and product ID seems to be a good candidate for it. Of course, there are steps we need to consider when defining the business key, as to check database and see if the table has a unique index, or to talk to business and query the data directly to find a unique set of columns. But let's assume that we already had these steps and identified the business keys. And each business key indicates to hub table. So we simply create two hub table and insert business key columns and create hash key value based on the business keys, and also add mandatory columns as record source and load date. So you may ask here why we don't have a hub table for product category. Actually, it's up to your business model. In our model, we just accepted that product category as a complementary characteristics of a product. So there is not any product without assigned to category. Therefore, we didn't create an additional hub and subsequently a link table for category. And it's also simplified the model and reduced the table numbers and hence the joins. Then another point is we also have order table which store the transactional data and order detail that shows the details of transactions. Transactions are the weak entities and don't have their own business meaning, because transactions occur result of interaction between the strong entities, in here customer and product. You remember that there are two approaches to model transactions. One of them is usage transactional link, which means we will model the transactions as link table and simply insert the identifier key from source table that makes our sales unique. And another approach is to model transactions as hub table. I will use the second method because I have one header transaction table and also detail of it. If I model both of them as link tables, then I need to create relationship between these parent and child link tables. And if you remember, link to link relationship is not recommended in the Data Vault. Therefore, I will also model order entity as hub table and insert order ID as business key. So the next step is the modeling of Data Vault is the creation of the relationship between the hub tables. We can obviously see that there is a relationship between customer and order, because there is a primary key, foreign key relationship, and the result of it, a link table between these tables should be created. We simply insert hash key columns from the concerning hub tables into link table. Then we will create its own hash key value. And each relationship represents unique combination of customer and order information. Then we will finalize it by adding record source and load date columns. And again, there is a relationship between order and product, as order details store many-to-many relationship between them. And we simply turn it to a link table as we practice many times for the bridge tables. And we will insert the hash key of order and product into the link table. And again, as we practice for all link tables, we will also create its own hash key value. There is also primary key foreign key relationship between product and category, but as we mentioned that we didn't create a hub for category, therefore no link is required as a result of it. Now we created the skeleton of the data vault, and now time to create satellite tables to store attributes. First, look at the customer entity. As we practiced a couple of times, we separate attributes to different satellite tables due to source system, type of data, and frequency of change. Therefore, by considering the frequency of change that will be different for each attribute, I collected the all contact, address, and main customer details into 3 separate satellites. Then look at the product information. As we mentioned earlier, I created one satellite for category information and another satellite for product. But depends on frequency of change or volume of source data, you can also bring them together into one single satellite. Then again we store the characteristics of order information as order date and amount into a satellite and attach to order hub. But please don't forget, in satellite tables we inherit hash key columns from the parent hubs which satellite is attached. And lastly, we have one more satellite for order detail, but it is a little bit different. We have a link satellite in here. So we embed all descriptive attributes that belong to relationship, which is quantity and price, into link satellite and attach to order detail link. Okay, we created our first raw data vault by converting 3NF model to data vault. It is very common that your operational system would be designed as 3NF and you could build your data warehouse with data vault solution on top of it. So now let's look at the further modeling steps. The next one is to tune your model. If it does not performing well, then we could extend the model by adding performance tables such as point in time or bridge tables, which are the part of Business Vault. This step is actually optional because performance will be relatively different for each organization and change even department to department. Some of them will demand to run queries in seconds and others would accept to wait for some minutes or even hours. Therefore, it is important to find out in here the expectations of your organization. So you simply would create an SQL query in here by involving the multiple entities and would measure the performance of the system. When we look at the scenario, one of the challenge would be we have multiple satellites in here attached to single customer hub. And the reason behind it, we simply separated attributes by frequency of change, because phone and email would change more often than birthday or name of the person. But because of these attributes change in different times, time interval for each version of data for an attribute is also different. In order to get consistent version of data from different attributes, hence the satellites, either we need to create complex subqueries or create bridge table. And we know that the subqueries are mostly identification of low performance. Therefore, we would create a bridge table which is modified satellite that helps to query data easily from a hub that has multiple satellites. Point-in-time tables are loaded from the source satellite tables and include the relevant hash key of connected hub, which is hash key customer ID, and load date of the point-in-time table, and maximum load dates for each attribute out of the satellites. After creation of the point-in-time table, we attach it to the customer hub, and from now on we can involve point-in-time table to our queries in order to find correct version of attributes from each satellite of customer. Okay, after extending our model with the performance tables, now we will check how the changes in source system will impact our data model. Let's assume that customers would provide different delivery address or pickup location for product delivery from their own address. And they would also share a deputy person that would receive the delivery. And due to change in business model, now we collect data in operational system and need to integrate it into Data Vault as well. As we know that one of the key architectural benefits of Data Vault is they can handle changes flexibly. So we could extend the model incrementally without impacting existing structure. So in order to add delivery information to Data Vault, We could create simply a hub table for delivery information by using delivery ID as business key, then create hash key based on it, and add mandatory columns as load date and record source. Then we will generate a link table between customer and delivery by embedding the hash key fields from both customer and delivery hubs, and also create link's own hash key value. Then as a last step, we will create a satellite table that is attached to hub and insert all descriptive columns to there. As you see in here, there is not any impact to existing model, so we can incrementally extend our data vault without changing our model or ETL processes. So we practiced a couple of modeling steps in this example. I hope that gives you overall idea about how to start and extend your model. So thank you for listening.